The median hinge point will allow the neural group to sink towards the coelomic cavity of the animal, and later on, wedging on opposite direction will also wedging on opposite direction will be facilitated by dorsolateral hinge points, as you can see here. These dorsolateral hinge points will later on allow the pinching off of the neural plate to become a closed neural tube, giving rise to three layers or three groups of cells. Right? So these three groups of cells again are the general cutaneous ectoderm, or you can say it as epidermal. You can tag it as epidermal ectoderm, neural crest cells, and your neural tube. Right. So that summarizes the process of primary neurulation. In um, in addition to primary neurulation, we also have another major event known as secondary neurulation. Secondary neurulation happens in, I'd say, posterior neural tube, or neural tube that probably will give rise to lumbar, caudal, or sacral areas of the spinal cord. In this process, um, the neural tube actually forms initially, and then cavitation happens. So it's slightly different in the sense that uh, there's no neural groove that develops. There's no canal-like structure that can be appreciated that later on encloses to become a continuous tube. But rather here, a solid rod or solid cylindrical structure develops first, and then later on cavitation is introduced to hollow out the central portion, later on becoming a central portion of the spinal cord, forming the cavity of the ventricles of the spinal cord. Right. So in terms of taking uh, a look at the process of primary neurulation in the model animals. In mammals, avians, reptiles, and amphibians, the process of primary neurulation is actually similar to all these four classes. They all or all these animals, if they undergo primary neurulation as developing embryos, will develop the three groups of cells: neural tube, epidermal ectoderm, and neural crest. Furthermore, okay, the process requires us to understand few factors. No? All right, as an inductive process, we can identify two important two important two important structures of the developing animal that are participating in the process. No? The inductive tissue and the responding tissue. For the case of primary neurulation, primary neural induction, we expect that our responding tissue is the ectoderm, and our inductive tissue is the mesoderm, chorda mesoderm to be more specific. As an inductor tissue, the chorda mesoderm is shown to produce an inductive signal. For many years, the inductive signal has been investigated. A few attempts or a few experiments have been conducted to determine the nature of the inductive signal. And one of the early successes in the establishment of in the discovery of the identity of the inductive signal provided us insights that noggin, a protein produced by the notochord, like coded by the noggin gene in chorda mesodermal cells, is actually serving as the inductive signal. But for to be more exact, this has been shown, or this has been